Welcome, everyone, to another edition of the Thoughtworks Technology Podcast. My name is Ken Mugrage. I'm one of your regular hosts. A little bit of an interesting panel today. We have both hosts and guests at the same time. I'll let them introduce themselves. First, Dr. Rebecca Parsons.
Hello, everybody. Rebecca Parsons, former CTO Emerita of Thoughtworks. I have been co-host for many of these podcasts, but in this particular case, I'm the guest to talk to you about fitness functions.
And Neal Ford.
Again, I'm another regular host of the podcast, but mostly here as a dual duty of both co-host and also guest, because Rebecca and I co-wrote both editions of the Building Evolutionary Architecture book, which defines this idea of fitness functions. And one of the frequent questions we get in the current day and age, of course, because no one can talk about anything except generative AI in the technology space, is, well, how does this concept of fitness functions apply to AI?
Yeah, so for the listeners, it's kind of interesting. We were just talking to the three of us before we started recording that this is something we've been talking about for a couple of years. Obviously, AI has been out for decades, but generative AI really kicked it off. And we were like, okay, how do you test these things? You have bias, you have the illities, which I'm sure one of our guests will get into a little bit. And fitness functions come up over and over. And so we thought we'd take a look at it. So first off, I guess just so everyone's on the same page, Rebecca, do you mind giving just an overview? What are fitness functions? Why do they matter? So
there is a strong influence from the field of evolutionary computation, whether it be genetic algorithms, but also more traditional optimization, where you have something that is your definition of good. Now, one of the easiest examples of this is the traveling salesman problem. And you have a list of cities that this individual is supposed to visit, and you need to order those cities to minimize the distance that the person has to travel. And it's that minimization of the sum of the distances that is the fitness function. And we use that in optimization techniques as a way of trying out different formulations of answers to see how I can get closer and closer. Now, with something like the traveling salesman problem and many other optimization problems, you can't guarantee that this is the best answer because of algorithm complexity, and we won't go into that. But as soon as you start to get into something a bit more complex, where you have two different things that you're trying to simultaneously come up with a good answer for, we get to use Neal's favorite word when talking about architecture, which is trade-off. If you want to maximize throughput on a production line, you have to minimize retooling. But if you also want to optimize the variety of things that you're doing on that assembly line, well, you can't maximize both of those, because every time you do something new, you have to retool the line, which brings down the overall throughput of the line. And so you have to decide what is the right balance point between overall throughput and the variety of things that you're putting on the line. Again, that measure of how many different kinds plus throughput of the overall line, that is, again, your fitness function. The single most important thing about a fitness function is that you and I will never disagree on whether it passes or not, on what the value is. So something like cyclomatic complexity less than 20, completely objectively defined, you just run the formula for cyclomatic complexity. Maintainable. No, because you and I can disagree. And so one of the challenges we have with a fitness function very often is taking this vague notion that we have that we want our code to be readable and maintainable and all of those kinds of things, is what does that translate into in terms of a fitness function, where there are things that we can measure where you and I will not ever disagree on whether something passes or not. Now, in the vast majority of cases, we want to be able to automate these things. And that's where the true power of a fitness function comes is once you've got a fitness function that's monitoring whatever characteristic, you don't have to think about it anymore until the fitness function flags up and says, hey, pay attention to me, something's going wrong. And so that allows you to apply our human brain power to things like what is the right balance point between the heterogeneity of our manufacturing line and our overall throughput. Where should that balance point be? Because that's something that, well, you have to discuss. Maybe it's security versus throughput. Maybe it's resilience versus some other characteristic. We're having to make decisions about what constitutes good. And for some things, like if you want to maximize the throughput on a manufacturing line, that's easy. What is the measure? What do you want the limit to be? When you start talking about something more complex, then you actually have to have a discussion of what is the trade-off? What is the sufficient amount of heterogeneity that I can get? And I'm willing to pay for that with the decline in overall throughput. Where is that point? And so that's where the real work of fitness functions comes in, is turning some of these vague notions or some of these trade-off situations into something you can measure and then test.
I was going to say, I really like Rebecca's example of throughput, because one of the ways that we distinguish traditional kinds of testing, like unit tests and functional tests, is that, and this really didn't come to us until we wrote the Head First Software Architecture book, but you can kind of split the architecture design into behavior, which is your domain, but then capabilities, which is where the ilities word come from, because it's describing capabilities. And Rebecca's example is perfect for that, because throughput, notice she didn't once say what we're manufacturing. It could be widgets or books or yoga mats or whatever. Throughput is a capability of the system, not the thing the system is about. And that's exactly true for fitness functions. We're measuring capabilities, the ilities of software, scalability, elasticity. And so this runs parallel to traditional kinds of testing. We're only testing the architectural behavior of the system, which brings us to, what sort of interesting architectural things, challenges does AI present that we can get to what Rebecca is talking about, which is something that we can agree on as an output for the outcome of the capabilities of one of these things.
Yeah, so one of the concepts in the evolutionary architecture book is the idea of guiding evolution. I don't remember anything that has moved as quickly as AI has been in the last couple of years, whether it be new models or new players or heck, new billing, right? So I want to change from this vendor to that vendor because it's a fraction of the cost. So do you feel like these fitness functions are a way to put boundaries around that? How can they help people in the incredibly fast moving world that we're in right now?
Well, I think I'd start with, what are your expectations around your use of these models? And it's those, again, behavioral characteristics. A very obvious fitness function that you might want to put into place for a product is to monitor what is the cost of the activities. And, that's pretty straightforward. X transactions time per transaction unit cost equals total cost. And if you can set a limit on it, or maybe you can set a rate on it, and you can throttle things if you're consuming your budget too quickly. But there are other ilities that are also quite important. Latency is a big deal. People have talked about the fact that if you use the free version of some of these models, then it takes longer to get a response than if you're paying for preferred access to the model. And latency is set to become more important with these chain of thought reasoning models that are coming into play, where they're building in the notion that the answer is not going to be instantaneous because it's got to think about it. And we like it. Studies have shown this all the time. For humans, when you ask a question, and if the person you're asking the question of actually pauses, you get the feeling that they really are considering your question. They're listening to you before answering, as opposed to me asking Neal a question, he immediately blasts the answer back. It's like, well, he's just telling me what he thinks I want to hear or what he wants me to hear. And I don't care what the question was. I'm going to give you the answer that I want to give you. But we're less tolerant of that with technology. All kinds of studies also show that if you don't get a response, people are abandoning pages, abandoning carts because it's just taking too long. So this whole notion of latency is going to become a big factor in how people view the success of some of these models. And that's before we even get into things like bias and hallucinations and things of that nature.
Exactly to Rebecca's point and to what Ken was asking about, if we need to move things quickly, it encourages us to define the capabilities that we need it to address. What kind of latency is acceptable in this architecture and build a fitness function around that, which allows us to swap out another model and see, does it still meet our capabilities that are required for success. And this is a particularly challenge when you move from prototype stage into production, because now we need to do it at scale. What kind of impact does that have on responsiveness or latency or this host of other things? And the ability to quickly play what if games by, well, let's build an anti-corruption layer for that capability and swap out this other thing and measure its capabilities in a realistic environment, I think facilitates this idea of being able to move quickly and swap things out at a rapid pace to match the ecosystem. Of course, we're never going to be able to match the ecosystem. It's always going to outsprint us, but at least we have more of a fighting chance.
Well, and it's also, this is a point we make for even the more traditional applications of evolutionary architecture. If you're not evolving your fitness functions, you don't have an evolutionary architecture either. Because as the technology capabilities increase, you might want to set your objective higher as a result of the increased capability. And so you need to constantly reevaluate what are the social and cultural characteristics, what are the business model characteristics, what's the regulatory framework, what are your customers' expectations, the technology landscape, how do all of those things come together that might affect how you define good? And at the end of the day, your composite fitness function, what I say is your target architecture is now the conceptual composition of all of your fitness functions, because that's what you're trying to get the architecture to achieve. That's what you're trying to get your system to achieve. We wanted to demonstrate these capabilities to this level, and this is what we're trying to achieve. And we're focusing on the outcome and not the implementation. And that's one of the big shifts in thinking about things like architectural governance that we get from thinking in terms of fitness functions is we're focusing on the outcome. Are you demonstrating this capability or not, as opposed to the implementation? Are you using this particular approach?
Well, in fact, and this is a little bit of a sneak peek for the upcoming technology radar, one of our themes is about how quickly observability is advancing, both in traditional distributed architectures and around generative AI. And to Rebecca's point, if you're not keeping up with observability, you're going to miss a lot of capabilities that are growing like mushrooms after a rainstorm. And we always see these hotspots of innovation in the software world that literally give you new ways to measure things or new ways to assess things, more objective ways to measure things. So it's important that you keep evolving your fitness functions. But lest we frighten people into, oh, this is going to be a huge burden. These things always change much more slowly and less aggressively than unit tests or functional tests, because unit tests and functional tests are literally changing all the time because you're growing your behavior and changing it all the time. You don't change your capabilities that much. You establish those capabilities objectively, and then you verify them very often. It's rare that you change the fundamental responsiveness or performance numbers in your architecture without other major changes, but you incrementally add behavior all the time. So you do need to keep them alive, but it's not a huge burden because because once established, now it's basically just acting as an ongoing safety net to make sure that we haven't broken something important.
So a lot of what we've been talking about so far is like systems that are using AI, but it may be a shock to some folks. There are systems out there still that aren't using AI, legacy and, others, but that said, especially developers and folks like that are really looking at AI tools to enable them to work faster. We talk about AI first software delivery inside Thoughtworks quite a bit, et cetera. What about using the AI stuff that's out there to work on fitness functions for other systems? I mean, have you been looking at that at all and how to help create and maintain these?
Yes. So there are really two aspects that we're thinking about broadly when you talk about fitness functions and generative AI. And one is using generative AI as a coding assistant, just like you would as a software developer. And one of the challenges people have is, I'd really like to write a structural fitness function, but now I've got to learn this new API, or I'm in an ecosystem that has Java and .NET. Well, I don't have to maintain a Java fitness function and a .NET fitness function, which is kind of cumbersome. My co-author on the Software Architecture, the Hard Parts book, and the upcoming book we're going to do, Architecture as Code, we've actually had great success by leveraging generative AI to describe what the constraint we want in architecture, basically in pseudocode, and then telling generative AI, give me a fitness function that matches the outcome of the pseudocode. And it's shockingly good at this, but in hindsight, we shouldn't be so shocked about it because it's a language model. It's really good at translating from one language into another, in pseudocode to Java or pseudocode to .NET. So what this allows you to do is to create a really terse declarative language that describes the structure of your architecture, the constraints of your architecture, what systems should be able to talk to one another, what systems should not be able to talk to one another, and then use generative AI to generate concrete fitness functions that you can put as part of your deployment pipeline or continuous integration and validate these things as you're making changes to the system. It's almost like it's a step between a traditional architecture decision record, which is, succinct text but text-based and diagram-based. This is a step between that and the actual implementation of a fitness function, which is sort of a pseudocode representation. So this gets around the barrier that architects don't have to learn a completely new API or have to write the same fitness function multiple times. They just express it once and then code gen the alternate versions of it.
And one of the interesting aspects of this, and this is something that I often get asked about, how do I define a fitness function? And some of them are incredibly straightforward. You don't want memory usage to exceed this, or you need this amount of throughput, or you want this kind of response time. Those are all very easy. One of the examples that I know I use, and I think Neal uses it as well, a very clever fitness function, which I think now in the generative AI days, people would have approached this very differently. But this was pre-LLM. And the lawyer for this particular organization asked, well, of course, all these open source projects are going to notify us when they change their license terms, aren't they? And of course, the development team just sort of laughed because no, they don't even know who is using their open source product. And the lawyer said, well, then we can't handle this. You must be able to tell me. And so they came up with a very clever, simple fitness function, hash all the license files and compare the hashes every time you do a build. And if they've changed the license file, the hash will almost certainly fail the hash check. And it sends an email to the lawyer. It doesn't try to do anything about understanding what the change is. It just says, take a look at this. This file has changed. Now, as they say now, people probably would have tried to be more clever and say, feed them both in and I mean, tell me semantically how these things are different. But then still they'd have to send it to the lawyers. So it wouldn't really have accomplished much. But very often figuring out what kind of thing can I define to establish the capability or describe the capability that I'm looking for. That's the real work in a fitness function. That's the intellectual work in a fitness function. As Neal points out, there can be implementation challenges behind these, but you still have to figure out, how do you give it the prompt? How do you come up with the pseudocode? And that does require you to think about, okay, what am I trying to measure here? And what is the best way to go about doing that?
So that makes me wonder if the concept of coming up with even the pseudocode is helping you understand the business better. Like, what are you really trying to get to? Is that an intended thing, or is that an unintended consequence? Or
I think it's very intentional. At least there isn't really any way you could approach this other than you have to think about this in the context of your business model and your customers and the technology landscape and all of those things. Even though, as in the throughput example, as Neal pointed out, I made no reference to what it was that was coming off that line. It is a business trade-off decision on what is the right balance point between the heterogeneity of the output and the overall throughput. That isn't something that some architect sitting in an ivory tower can decide all by himself. It is a business decision. And we have to think about this in the context of what we are trying to achieve overall as an organization. Now, the hash file example, that's still a business question. They were trying to address the problem of, how do I make sure, the crown jewels of my proprietary code aren't accidentally leaked because somebody changed a license file and now I have to make my crown jewels public. That's a business concern.
Well, and I think at the end of the day, the beneficial side effect of this is it encourages architects to try to objectively define things, because once you get to objective definitions, you can verify them and test them. And it also facilitates, we see too many organizations where they use a lot of vague terminology like, oh, we want really good performance. Okay, well, write me a fitness function for good performance. That's meaningless. Tell me some numbers within a range of how you want performance. Now I can write a fitness function for that. So just the encouragement of boiling it down to concrete measurable things, because very often in the exercise of getting down to concrete measurable things, you'll realize what the real constraints are that you're up against early, rather than very late in the development process when you realize, oh, this will never actually achieve that level of performance. So that is a very intentional benefit of going through this analysis to figure out what your fitness function should be.
So who owns these? I mean, and let me tell you why I'm asking that. I used one of these tools the other day to refactor a little application with the expectation that now the test would fail, and it didn't. And I'm like, what the heck? Well, it turned out this tool went and refactored the test too. And it's like, well, didn't really want that to happen, but, if it had been, not to get too in the weeds, but in a separate code base or something else, that wouldn't have happened. But who owns the fitness function in an organization?
My answer to that question is usually yes.
Okay.
So architects typically write them, but developers are going to trip them and fail them. So it's really, really important to have developers understand what these things are for, because they're going to be the ones that make them fail and then have to fix them, which is a little bit annoying, but it's really the same function as unit tests and functional tests. Look, this is insurance for the future. If I break this fitness function now, that means I was about to make a change that's going to break some capability that's important. And it may be a small thing now, but left unchecked, this is going to be a disaster in 6 months. And so it has to be joint ownership. One of the things that very early on, when we were writing the first edition of the book, we realized that we were giving architects a very sharp stick with which they could poke developers if they wanted to. And we told them, please don't use the sharp stick to poke the developers. You shouldn't create an antagonistic, a police state with fitness functions. This has to be collaborative, because You need to share the understanding. And in the same token, developers are going to run across things that really should be encoded as fitness functions, and they should create a feedback loop back to the architect to do that. As I said before, the burden of these things is not nearly so high as adding, a new unit testing framework or, a practice like unit testing. Because once established, these mostly just sit in the background and hum along and only warn you if something dire is about to happen. And, I think you want warning if something dire is about to happen, even if it does cause short-term inconvenience.
Yeah, and I think there are particularly more complex enterprises. You probably have some hierarchy of architects. Neal just used the architects, own them because they're architectural characteristics. But some might be for a business unit versus the entire enterprise. And we like to get the ownership and the decisions around those fitness functions as close to the team as they can get, because there you can start to bubble up. Well, wait a minute, this thing you've just given me, this conflicts with something very specific in my environment. And we have now one of these conflict trade-off situations where we have to have a discussion about it. The more understanding that the team has about why these fitness functions exist and what they're trying to protect, the more fruitful those conversations can be when something new does come up and it conflicts somehow. There's things, that are done at an enterprise level, probably related around cyber, would be one example, whereas some other things, if you're working on a primarily internal application where you've got a small department of people doing a function, your scalability requirements are going to be very different from something that is customer facing, where you want that to have to scale because you want to increase your customer base. You don't necessarily want to increase the number of accountants or whatever the internal function is. And so they should be as close as possible to where the problem is, because that's where the understanding of what those right levels are resides.
So there's a couple things in a application that's built around AI, or especially in the new world of generative AI, that have been an issue with applications forever, but they really come higher up, and it's the bias, of course, but then also the relatively new concept of hallucinations. Are fitness functions helpful in either of those areas? If so, how?
In particular, when you think about bias, yes, you can write fitness functions for it. You can have, let's say you are you're doing some kind of credit application or credit scoring, something like that, and you can set up mock profiles that exhibit different characteristics and see whether, okay, does this version of my credit scoring product discriminate on the basis of gender or race or whatever. That's where that intellectual process comes in. Where are the likely sources of bias, and how can I best expose them? And again, being focused on the outcome, not the implementation. You don't really care at the fitness function stage why that credit score for the man was higher than the woman when everything else was identical. You don't care about that. You just care about this is demonstrating bias because all other things being equal, it gave more money to the man. When you start to talk about hallucinations, I think that becomes more difficult. I still think fitness functions have a role to play. It could be something trivial like if you can determine that this answer came from a source, can you actually hit the source and have it retrieve something other than a not found? That would take care of many of the issues for things like made up articles, made up case law, things of that nature, because if you tried to hit that, it would come back as it would come back as not found, whatever that might be in terms of case law, as an example. And so That's not going to stop all hallucinations, but it at least gives you a place to start. And this goes back to what I was saying before about how the intellectual effort around a fitness function is really understanding where the problem might come from and how can I test that? How can I define it in such a way that we can actually test that?
Yeah, that's a great example of, LLMs have given us all these brand new capabilities in our system, but then how do we check those things, objectively measure those things? And that's a great example for hallucinations. Can we follow this link, in a protected sandbox or something? Because we've seen examples now of people so if an LLM commonly hallucinates something, a link, we've seen malicious actors put bad code behind that link so that naive people will pull that into your project. So having a fitness function that checks in a sandbox to make sure that, it's a legitimate site, et cetera, would be one way to protect against that. But to Rebecca's point, and this actually goes back to a question that Ken asked earlier, this really encourages the team to start thinking about how can we objectively measure the capabilities of this black box? Because this is unique in most things in the software development ecosystem, where while software sometimes acts non-deterministically, it is actually deterministic, but LLMs are not. They're fundamentally not deterministic. And so coming up with ways like for bias, a great example, because it may give you different answers with the same inputs. So how do you check to see the important parts of that can we objectively measure versus the minor differences that may occur because of, wording or semantics, but, the fundamental meaning of it. Is it aligned with what we want it to be? Another great example of a fitness function around an LLM is actually a pattern that we saw identified by one of our teams, which is how can I make sure that the output of my inexpensive LLM is good enough? And they basically built what I would call a parity fitness function that took some of the output of the lower cost LLM and ran it through a more expensive LLM and compared the results to see if it was in an acceptable threshold. That's a cost-saving fitness function for an LLM, but it's very much a kind of a parity or fidelity fitness function to say, this is something that's running in the background to verify we've made a business choice for this less expensive LLM. Can we objectively measure, are we getting the right, an acceptable level of what we want out of this solution?
And some of them are trivially obvious. Very early on, for example, many people put in filters to make sure that people were not sending to the open internet models personally identifiable information. You can scan for some of these things and say, no, you cannot do this because that's wrong. And so in cases like that, it's pretty easy to define what you're trying to achieve. You're trying to protect people's data, or you're trying to protect your intellectual property, and therefore these things can't go out. That, again, is a fitness function that is monitoring, in this case, more a person's behavior rather than the system's behavior. But again, the capability that you are trying to achieve is data privacy or protection of intellectual property, things of that nature.
So what I'd like to do is ask you each to put on your futurist hats. I know you love it when I do this, and you can pick your own time frame. But I guess Neal, I'll go to you first. What should people be watching for in what time frame?
So it's a great question, of course, and I can guarantee that whatever we speculate about now will be wrong, and the more into the future we speculate, the wronger it will be. So that's almost a given when you put on some sort of genie hat like this. The main challenge I think we're going to face in the near term is not actually the really cool, interesting part of LLMs. It's the drudgery of productionalizing this stuff. As architects, I mean, as tempting as it is to want to crack into the LLM and fine tune it or build all these capabilities, that's really more of a specialization. This is like, sitting down with your data scientists and pushing them out of the way and starting to mess around in their notebooks and stuff. That's probably not what you should be doing unless you have expertise in that area. But what we do have expertise in is putting these things in production. It's great to do these little demos, but then having that demo operate at scale can sometimes be really challenging. And I think what this is going to do is put even more emphasis than we've had in the recent past on coming up with, what does success mean in terms of capabilities here, and how can we actually measure those things? And, ironically enough, once you've identified those objective measures, you can have the LLM help you generate the guardrails around itself to be able to check those things as you move forward. As you said earlier, Ken, we are in a perhaps short-term, maybe longer-term bursty growth era in the software development ecosystem. And it's more important than ever if you're going to play what-if games with all these different capabilities. So there are all these different capabilities that are coming up, and we identify hotspots of innovation. So again, on our most recent radar, we highlighted the R in RAG for retrieval augmented generation. We didn't highlight the augmented or the generation part. It was R's time in the spotlight. But the next radar, it's going to be something else. And so as we have all these capabilities with explosive growth, it's good advice from the domain-driven design world to put some of these capabilities behind anti-corruption layers, which is just a fancy word for an interface, so that you can swap it out with new things that are coming down the pike. But you also want fitness functions to verify that, I've easily swapped out one RAG database for another one. Now, does it still meet my performance, my responsiveness? And so that's the safety net for allowing you to have an aggressive stance toward incorporating some of these Gen AI elements, because you can get rapid feedback for, is this making things better, or is it just, clouding things or degrading something that we didn't expect it to? Oh, look, we get much better responsiveness, but look, it doesn't scale. And so, finding out that balance of things, this goes back to what Rebecca was talking about, balancing these concerns. This helps you do that because you have objective measures for what's going on. So I guess my time frame is like 6 months in the future. So that's as far as I'm willing to speculate.
And I always say my crystal ball is still broken. I've been involved in AI for a very long time. And so I have seen the succession of AI winters. I am starting to see more references to where we are on the Gartner hype curve, and different people put it closer to the precipitous drop into the trough of disillusionment. One of the things I think we are starting to recognize is there are capabilities that truly are revolutionary in what we've come up with LLMs and how we can use them. But it is not a silver bullet. And I think one of the reasons, for example, that we see such a low rate of actually productionizing many of these pilots is the fact that it's one thing to clean up your messy data so that it works for your group of nice, well-behaved, customers who aren't going to complain too much. But trying to scale that to your entire customer base is much harder. And so I think one of the things, just like in many of the data science applications that were coming out before LLMs hit the scene, if you don't have a good data base to work from, you're not going to be able to deploy these intelligent products that rely on that data. And so I think one of the things that we are going to see, again, in that short term, is a lot of resources being thrown at how do I clean up my data? This may, in fact, be the time when we finally get rid of those. Well, in the period of time between November 4th, 1985 and January 12th of 1986, this field meant that, and, there were landmines like that all over these enterprise data sets. People talk about bit rot and how code deteriorates over time. Data, the older the data is, the much more likely it is that it doesn't say what you think it says. And so I think we're going to have to deal with that. I also think that we need to distinguish the Gen AI trajectory from the AI trajectory. And what people think of Gen AI in terms of things like natural language and all of that, there are capabilities that are being developed in other disciplines that I think we're going to see move productively more quickly than some of the things. I don't think we are on the cusp of AGI, and I'm not even sure that I think that AGI is the right kind of objective at the moment. And this might be more wishful thinking than anything else, but maybe we can start to understand, here's the sweet spot. LLMs have a sweet spot just like every framework has a sweet spot. Here is the sweet spot. This is the stuff that it does really well. And let's figure out how we can exploit that.
Great answer. It's all about the data. Yeah. So I want to thank both our guests. Again, the book Fitness Functions are a big part of it, but there's a whole lot more to it. Is Building Evolutionary Architectures, Automated Software Governance by Neal Ford, Rebecca Parsons, Patrick Kwa, and Pramod Sadalage. Am I saying his last name correctly?
Sadalage. Pramod Sadalage. Yep.
Sorry, Pramod.
Yeah. That's I had to learn to pronounce his name when he became a co-author, so it's a tricky one.
But it's available at a bookseller near you and your Kindles and all that neat and happy stuff. So again, thank you, Neal Ford. Thank you, Dr. Rebecca Parsons, for your time.
Thanks,
My
Ken.
pleasure.